seated nice and easily. So it's on. You heard the click. Now how do we get it off? I'm done with this. It's a little bit dull. Same way as you get it on, you're going to grab pinch, peel it up like that, and push forward. Then it just goes in the sharps container. Got it? And that's all there is. So these are going to be the only sharps. We're not going to have any needles, so that's the only thing we have to worry about as far as this is concerned. Alright, so go ahead and reveal. Go to town. Start cutting. Those of you that go into medical school later on, the first class that you have is a cadaver lab, where you will actually take a human being and you're going to start at the head and neck and you're going to go all the way down. You start at the head and neck because that rots out first. And by the time you get down to the feet, they're going to be blue and they're going to be green and they're going to be all kind of chunky and hard to dissect and hard to get through depending on how fast you go. But when you come in, you'll have a room like 10 or 12 bodies, cadavers aside there, and you'll have so many people per cadaver. And then you'll start at the top and you'll have a lecture for the day. They'll go over the parts in the lecture, and then you'll go and you'll cut and you'll try to reveal. Then the next day you go and you cut and you try to reveal. And as you go through, you're dissecting this guy all the way down to the bones and beyond. And there's a big tub underneath that you just take all the parts, like this adipose that we just take it and put it in the tub, because later on when we're done with the body, we get that tub and we incinerate it, and that's how you tell you're done with the person. So easy enough. I think some nursing schools might do it as well. Now, if you remember, this is for cutting. So if I wanted to cut with this, I'm going to slice. It's like this. We're not actually going to wedge through it, so it's going to be, and the easiest thing you can do is like this. Did you also notice there was like a layer on top of it? That's a fascia. Fascia is not like, oh, you need one. Why do you need, here, set it up. Fix yourself. Every organ inside your body, when it forms, it starts out with a germ cell. A germ cell is just a cell that's it's called totipotent. It can turn into anything. Like stem cells, when they talk about in research, you take a stem cell, you can grow it into something later on. Like if you miss an organ, you can grow an organ. So every time something starts to grow, it grows a sac around it. So it grows a fascia sac, which is why when you eat chicken or something like that, you'll see the chicken, and then when you peel the chicken, there's that white membrane on it, and then you get to another muscle, then there's another white membrane. So when you're doing this, that's exactly right. That's going to be the fascia. It's that little pull, and it's really tough. All it is it's a really nice, thick membrane. If it's a really tough mama jamama, then it's called an aponeurosis, which you'll find out they just give you words to mess with you. Would you hand me that heart? Oh.
Nobody can hit it. You don't have any clothes on it. Look at you like, what? You want me to touch that?
You better get the salt ready. Somebody's about to pass out.
You need it. What do you need?
I was going to cut this open so we could see the ventricles.
But you need what do you need?
I'll just borrow some scalpel real quick. Thank you.
Keep me on the table side. That's how I do it.
Well, I need you to fix it.
Yeah,
This
that's
kind of
it.
stuff over there.
Yeah, that's it.
And that EKG machine and that blood pressure stuff over there.
Took me a while, found them.
Something squirts out of there. Yeah, I'm gonna get this one.
They were actually next to me.
Thank you very much.
No, no, well, good.
This is something for them to do right in labs. They do a lot of blood. They do assist with a lot of minor office surgeries. Now they're gonna do that in surgery, but they have to do a biopsy. They have to assist with that. They gotta do they have to do any kind of invasive surgery. When they go
Now, as soon as I get this open, I'll show you guys somewhere else how to start doing sutures, so we can basically have two tables going on at once.
And then these three here are surge techs. Okay. Right here.
The heart is literally the strongest muscle in your body. It also operates on its own special little biochemistry. The heart is all about calcium, whereas the other muscles are all about starting off with sodium. So the heart, being like that, especially the atrium, allow us to cater to it with some specialized kind of medications called calcium channel blockers. Have you ever heard of those? Whereas sodium channel blockers are going to work a little bit different. If we look inside the heart, the interior chambers of the heart are actually filled, and it looks more like a spider web. You see these cords right here? This is the valve. These are the cords that actually attach to the valve. You see these cords? These cords are called chordae tendineae. They're made of a special kind of really strong connective tissue. And the idea is, if I have a hole going this way, and I have flaps that let the blood go through, flap lets the blood go through, lets the blood go through. Well, if I'm in the atrium and I have a low pressure, I'm going to squeeze the blood into the empty ventricle. Whenever the ventricle now wants to squeeze, the ventricle has a higher pressure, a stronger wall than the atrium, so what would naturally happen is the blood would be shoved back. But we don't want that to happen. That's called regurgitation. That's a disease. So what happens is these flaps that went this way are anchored on the opposite side by these cords, just like parachute straps. So whenever this heart is full on this side with fluid and it squeezes, as the blood starts to go through, it pushes those flaps closed, but when the flaps close, the cords pull taut, so now it can't go the opposite direction. So now the only way for the blood to leave is through the blood vessel going the other direction. So that's how your heart works. The top part squeezes to the bottom part. When the bottom part squeezes, the blood cannot regurgitate backwards because of those chordae tendineae. And then it's forced to go out to the rest of the body. On one side it's going to go to the lungs, on the other side it's going to go to the rest of your body. But that's how it works. If you have something where those flaps are really stiff and they don't open because calcium or diseases caused a problem, that's called a stenosis or a stiffening. If you have it to where it kind of gurgles back and blood leaks through anyway, that's called regurgitation. And both of those are going to cause murmurs. And that's why you hear when someone has a heart murmur, that's the problem, or that's the basis for the heart murmur. So, anybody want gloves to play with this?